Hi guys, today we're going over USACO 2016 Square Pasture. So in this problem, it's more of like a visual problem than the other ones that we've been going over. So Farmer John has decided to update his farm to simplify the geometry. Previously his cows grazed in two rectangular fenced-in pastures, but now Farmer John wants to replace these with a single square pasture. And he wants the square pasture to have a minimum size that covers both of the rectangular fences. So if you think about it, obviously the area of the new square fence has to be equal to or greater than the area that was made with the rectangle fences, whether they overlapped or not. So in our problem, basically, all we needed to do is find the minimum area that Farmer John needs to use to make his new square pasture. So if he places it appropriately, he can still cover all area formed by the two older rectangular pastures. And that square pasture should have its size parallel to the x and y axes. So it shouldn't be like tilting in any way. And that makes it just easier for us in general. So the input format that we're given is that the first line in the input specifies one of the original rectangular pastures with four space separated integers x1, y1, x2, and y2. And the lower left corner of the pasture is x1, y1, and the upper right corner of the pasture is x2, y2. And the second line does the same thing, but it's for the second pasture. All right, so this would be, if you look here in the sample output, this would be the lower left corner of the first pasture. This would be the upper right corner of the first pasture, lower left of the second, upper right of the second. And for our output, we need to output one line. That's just the minimum area required of a square pasture that would cover all regions originally enclosed by the two rectangular pastures. So in this example, the first original rectangle has these corners, we established that, and the second has these. By drawing a square fence of side length 7 with corners 1, 6, and 8, 13, the original areas can still be enclosed. And this is the best possible since it is impossible to enclose original areas of the square's side length of only 6. Now that's a lot of words. Basically what it's saying is that these rectangles are going to overlap and there are two sides in which they overlap. We don't want to use the smaller side because if we create a square with the smaller side, we're not going to get the full, we're not going to get both pastures fully inside that square. So we're going to use the longer side of the overlap and we're going to build a square around that. Um, After reading this, I'm just going to draw it out so it's much easier to understand. Um, but basically, there are several different valid placements for the square of side length 7, as it could have shifted vertically a little bit. So yeah, this explanation was quite a bit of words. Now let's go ahead and I'll just draw it out for you guys. Okay, so here we have a little diagram and it shows both of the rectangles that we have. So first one, we have the rectangle with these coordinates. Second one, we have these coordinates. And notice how I've made a rectangle that basically includes both of the pastures. It's the minimum size required to include both of the pastures. Obviously, it's not a square, so it's not our final answer. But notice how I got it. So I basically took in every single x coordinate, right? And I looked for the smallest one. That's going to be 1. So since that's 1, that's going to be our 1 is going to be the x coordinate for the lower left hand square. And now I look for the smallest y coordinate. 6, 8, 8, 9. Looks like 6 is our smallest y coordinate, so it's going to be 6 here. And I do the opposite for the top right. So I look for the biggest x coordinate. 1, 4, 6, 8. Looks like 8 is the biggest. And then 6, 8, 8, 9. Looks like 9 is the biggest. So my minimum rectangle, that's how I'm going to find the side lengths for it. Or I guess the points for it, for the lower left and the top right. And now that we have our minimum rectangle, we can determine how long the sides are. So for this side, it's going to be 3. For this side, it's going to be 7 units. And if we made a square, a 3 by 3 square, right, then it would not include both of the pastures, as you can obviously see. Um, because if we include just like up to here, then it's not going to work. It's not going to include this pasture. So we need to make a square pasture of that has both side that has an area of 49, right? So both side lengths are 7, and it's going to just kind of look like this, right? Um, so yeah, basically we just need to find the square pasture that works. And it's just going to be the bigger one. So we're just going to choose 7. And yeah, that's how we find our our square pasture that works. So now we can move on to the programming portion. Okay, so as you guys can see, I have some static variables already set up. So all these 8 static variables are basically just the coordinates for the squares or the rectangle pastures that we have initially. So this is going to be the first x and y coordinate for the lower left corner of the first pasture. This is the top right of the first pasture, lower left of first pasture, top right, lower left of second pasture, and upper right of second pasture. You can tell that it's the first pasture by the A that comes before, and the second pasture by the B. And then after the X, the 1 means that it's the lower left, right? And then the 2 means that it's the upper right. So you guys get the idea. We have our standard in and out and init and solve here. We close those later. So the first thing that we want to do is set these up. So we're gonna just take them in the order that they're listed. So ax1 equals integer dot value of, and then we're gonna do st dot next token. And basically there's gonna be 4 of these for the first thing, right? So we're just gonna do this, but it's gonna be like a y1 and then ax2 and then ay2. Right? So this is just the order that they're going to be taken in. Pretty self-explanatory, right? And then we're going to just take in the next line, and we're going to do the same thing, except it's B now, not A. So that's pretty much all we need to do. Oh, and it looks like I accidentally put an X there, so we'll just remove that. So yeah, that's how we take in our variables. Now that we've taken them in, we're ready to go. So we need to find the minimum y and the minimum x of our minimum rectangle, right? So the rectangle that has that just barely includes both of the rectangle pastures that we started off with. So we're gonna do that by doing int y min equals math dot min, right? Because we're trying to find the smallest. And then we're going to do another math.min. And then we're going to do ay1 and then ay2. And then we're going to do another math.min. And then we're going to say by1, by2. What this is going to do is it's going to find the smallest y coordinate of all 4 y coordinates that we're given. And obviously that's the one that we're going to use for the y, right? The lower left corner of the rectangle that we were talking about. That's what we're going to use it for. And then y max is going to be the opposite. So it's just going to be the maximum. So we're going to change all the mins here to max, right? As you can see, there's a lot of repetition in this. And then we need to find our x min coordinate. So we're just going to change everything that's x here into y. So this is x, x, here, here, and here. So now we found our minimum x coordinate. And then we need to find our maximum x coordinate. So we're just going to change everything to x here as well. Okay. So we found our minimum x and y, so our minimum lower left corner, and our maximum, right? So it's going to be our top right-hand corner of the minimum rectangle that just barely contains both of the pastures that were given. And now we need to find which side is bigger, and we need to determine our area. So what we'll do is we're going to we're going to say int area equals math.max, and then we're going to say that's going to be y max minus y min, and x max minus x min. Okay. The reason why we do this is because the side lengths of the rectangle is these. So this is the vertical side length, right? And then this is going to be the horizontal side length. So we're going to determine which one of these is bigger, and we're just going to multiply that by itself. Okay, so we're going to do out.println and then just area times area. That's all we need to do because remember it's a square and squares are just side length times side length. To make it more understandable, right, just so we don't get confused, I'll actually rename this to side, but it's the same concept, right? So that's all we're doing. It's just we're trying to find the bigger side of the two sides, and then we're outputting the area of that square, okay? So now that we've done that, we're ready to submit. Yeah, so our program passes all of the test cases, as you guys can see. So that's the Square Pasture problem. If you guys have any questions or want me to go any problems in particular, you can feel free to leave any of those in the comments. Otherwise, thank you for watching.